Alright, so my next subject is on spread and box plots. So, spread is kind of that third thing that goes with the quantitative variables. But there's a lot more to it than shape and center. So, I wanted to give it its own thing. So, we're going to talk about what is spread, what are the different types of spread, how can you identify an outlier? Again, excuse my English, apparently I can't write the word and, I have to write the word and. And how can you create a box plot? So what is spread? Spread is something that describes how far apart the data is. If points repeat each other a lot or are very close to each other, the spread will be small. If points are further apart, the spread will be larger. So essentially what spread does is it tells you how varied the data is. So if I were to have, say, this data here, and then, so this is data set 1, and then data set 2, let's say it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, we would say that this data set is much more variated, or the spread is much larger than this data set, simply because there's more points and the range goes across it. So let's explore the different things that we could use to represent spread. So the first and most easiest one is just the range. So how do we display the spread? Range is one of them. We just do the maximum minus the minimum. It's also the easiest way. Now, all of these happen to be in order, and I can just do these right here. To get my range, I'm just going to do 20 minus 8, which gives me 16. Okay. My range here is 50 minus 12, which gives me 38. 67 minus 3, which gives me 64. So those are my ranges. And so if I had to order this data from largest range to smallest range, so largest to smallest, and largest to smallest spread, it would be C, B, and then A. Okay, and then, let's see, number 1, number 2, number 3, number 4. If I try these out here, same thing. 40 minus 4, largest, smallest, gives me 36. 34 minus 2 gives me 32. 61 minus 5. Now, these just happen to be ordered. They don't always have to be first and last. But 61 minus 5, let's see. 46, no. Yes, 46. Why am I hedging? And then 78 minus 1, which gives me 77. So 4 here has the largest spread, then 3, then 1, then 2. And that's all of our ranges. And ranges is pretty easy. Now, what about standard deviation, which is one of the hardest ones? Now, some of you out there have probably seen the formula for the standard deviation, which is, let's see, x minus x bar. Whoops. The summation of x minus x bar over n minus 1. Am I missing anything? Nope, I think that's it. Square root. I could probably write that a little bit better. Let's just do that right there. Oh, and I did miss one thing. So this is the formula. And this is also, for anybody who wants to point out, this is considered the sample standard deviation. the population standard deviation would just take the -1 out, but I'm just worried about the sample standard deviation in this point. So what we're going to do though is instead of trying to follow this formula here, we'll break it down into some steps that are really easy to do. So what is a standard deviation? It is the data point's average distance to the mean. It's kind of the hardest way to do it, which is why for my class, for the most part, we will be sticking to doing stack crunch, but we'll break it down a couple of times to see how to do this. What are the steps? We're going to find the mean. We're going to subtract the mean from each data point. We're going to square all the results. We're going to add all the squares. We're going to divide by the number of terms -1. So terms -1. And this finds the variance. And then we're going to square root, and that gives us our standard deviation. So basically all of these steps here is basically this formula right here. So let's see what that is about. I'm going to bring up my notebook. So we got 7, 12, 15, 22, 25, 31, and 49. So that was my data set from the previous one. I'm going to do all of the steps to get my standard deviation. So the very first thing I'm going to do is I want to add these up and divide by 7 or find the mean. That's the very first thing I want to do. So if I add these all up and divide by 7, 7 plus 12 plus 15 plus 22 plus 25 plus 31 plus 49 gives me 161 divided by 7. That gives me 23. Okay, so the next step is I'm going to take all of these points up here. So 7, 12, 15, 22, 25, 31, 49. I'm going to subtract the mean. Okay, so let's see. 7 minus 23 is -16. 12 minus 23 is -11. 15 minus 23. I want to make sure I get all these right. I don't make a mistake. -8. -1. +2. Let's see. 8. And I think it's 16, but let me double check. Wait, nope, 26. I was off by 10. Okay, so that's my differences. Then I want to square. Okay, so I know 11 squared is 121. Now remember, when you square anything, it's going to come out to be a positive number. There is one case where it doesn't, but we're not worried about that in statistics. But it's always going to come out to be a positive number. Okay, 16 squared is 256. I do want to double check that real fast. But I know it ends in a 6, so it should be 256. Yep, 256, and then 26 squared should also end in a 6, but that's 676. Okay, so now I'm going to add all these together. Gives me a grand total of 1,186. Okay, so now I'm going to look over top here and I'm going to say there's 1, 2, 3, 4, 5, 6, 7 data points. And so since there's 7 data points, I'm going to take that number 7 and deduct 1. Because this is where I'm going to divide by the number of terms minus 1. So 7 terms up here, minus 1 is 6. So we're going to divide by 6. And I guess technically if I was being technical, I would just make that 2/3, but I'm not going to worry about it because I'm going to take this number now. Now before I go on, this number before I square root it is called the variance. Okay? It is used in statistics sometimes, but for the most part, we just stick to using the standard deviation. But that is the variance. So now, standard deviation is the square root of this. So you get 14.0594. And this is my standard deviation. Not too bad. Let's take a look at the other one real fast. So we got 10, 14, 21, 25, 30, 38. So, same thing, I still want to find my average, so get 138, I add them all together, so 138 divided by 6, and weirdly enough, I made my average 23 both times. Was not trying to do that. So 10 minus 23, 14 minus 23, 21 minus 23, 25 minus 23, 30 minus 23, 38 minus 23. So once again, I need to subtract these. I get negative 13. I get negative 9, negative 2, 2, 7, and 15. Now I'm going to square. So that gives me 169, 81, 4, 4, 49, and then 225, I'm fairly certain. Just double check that real fast. Yep, 225. You always want to be certain about these things. Okay, so then I'm going to add everything up. 169 plus 81 plus 4 plus 4 plus 49 plus 225. Gives me 532. Okay. Then I'm going to take this and divide by the number of terms minus 1. So I had 6 terms before, so that gives me 5. Dividing by 5, it gives me 106.4. And I'm going to square root it. And it gives me 10.3. 150. Okay. Excellent. So that's how we find ourselves standard deviation. Again, this is a points average distance back to its mean. Now, when you have like 6 or 7 points, that doesn't really show up well. It's more of a process when you have a lot more points, but trust me, you would not want to do this process with 30 or 40 points, which makes you kind of feel good about having actual statistical software to do this stuff, no longer by hand. But that's a standard deviation. Now the last leg of this is talking about a 5-number summary and box plots and stuff. And they all go kind of together. So a 5-number summary is another way to talk about spread. It's 5 specific numbers that explain the spread of the data. These numbers are the minimum, the quartile 1, the median, the quartile 3, and the maximum. Quartile 1 is the median of the smaller half of the data. Quartile 3 is the median of the larger half of the data. So these numbers are kind of, when you hear them, they don't make a lot of sense until you actually see them in practice. So that's what we're going to concentrate on. We're going to see these in practice with my data sets here. So I'm going to start off with these data sets here. And always feel free, after I do the first couple of examples, to pause the tape, do it yourself, and then see if you're going to get them correct yourself before you get the answers. But I'm going to write these down on my piece of paper here, and we're going to find a 5-number summary. So we have the numbers 8, 9, 10, 10, 11, 12, 14, 15, 16, 16, 18, and 20. Okay. So the first thing I need to do is I'm going to label what those numbers are. So we have the minimum, which is pretty easy. The minimum is always the smallest number. So that's 8. We have the Q1, which we'll come back to. We'll have the median, which is the middle number, but we'll come back to that in a second. We have the Q3, and we have the maximum. And Q1 and Q3 stand for quartile 1 and quartile 2. Now the maximum we know is 20. Okay, so now, let's get this up just a little bit more. Okay. So the next thing I want to do is we want to find the median. So if we remember from my last lecture, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 data points. That means the median is going to be 2 numbers in the middle. If I cut 12 in half, it's 6. So 1, 2, 3, 4, 5, 6. So it'd be these 2 here. So what I'm going to do is, since it's those 2 there, I'm going to take the average of those 2, which gives me 13. And that 13 is not part of the data. I'm just going to put it right there. Now what that does is it cuts the data completely in half. So now I have 6 points down here and 6 points up here. See, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So now what I want to do is, to find the Q1, I want to find the median of just this lower portion right down here. So everything below the actual median itself. So again, that's 6 points. That means it's going to be in the middle, and it's going to be the average of 10 and 10. Now, luckily for me, the average of 10 and 10 is 10. Okay. Then I'm going to go to the top here. And I want to find for Q3, I want to find the average. No, I'm sorry, not the average. I want to find the median of just this portion up here. And once again, it's going to be the average of those 2. But again, luckily for me, the average of 16 and 16 is 16. So that is my 5-number summary. And what that does is it breaks the data into quarters. So between every set of 2 numbers is 25% of the data. It's neat. And then we also have something special between Q1 and Q3. So between Q1 and Q3, we call this Well, first is the central 50% of the data. And we call this the interquartile range, or IQR. So I'm sure you've heard that before. And IQR, all you do is you just take Q3 minus Q1. In this case, it's 16 minus 10 to get 6. Now, we're not going to do this for every single one, at least not yet. When we start talking about finding outliers, we'll start calculating the IQR more. But for right now, we will not be calculating any more IQRs until we get to that step. All right, so let's look at the next one. So we got 12, 14, 14, 15, 17, 18, 19, 21, 21, 22, 24, 25, and 50. Okay. So let's see. I still need my min. I need my Q1. I need my median. I need my Q3. And I need my max. So min's easy. It's 12. The max is 50. The median is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 1 in the middle. Let's see, half of 12 is 6. So 1, 2, 3, 4, 5, 6. And that should be the median. 1, 2, 3, 4, 5, 6. Okay, now, when there's just one data point in the middle, we just get rid of it so that it's 6 and 6. So we use it on either side, then the data becomes unbalanced. If you use it over here, points. If you use it over here, it's 7 points, and the other one will have 6 points. So when we have that 1 in the middle, just cross it out to not use for the calculations for the Q1 and the Q3. Okay, so now all I have to do is find the median of this lower half. That's 6, so that means I'm going to find the average of 14 and 15. So that's going to come out to be 14.5. And if I go up here, I need to find the average of 22 and 24. Again, there's 6 points. So 22 plus 24 over 2 gives me 23. And that is my 5-number summary for that data point. Okay. So final one I'm going to do here is my C, so 3, 4, 21, 22, 22, 24, 25, 25, 26, 26, 56, and 67. Okay, so same deal. We got a min, we got a Q1, we got a median, we got a Q3, and we got a max. Okay, so again, my min is 3, my max is 67. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, that's an even set. A split of 6 and 6. 1, 2, 3, 4, 5, 6, and 6. So I want these two here. 24 plus 25 divided by 2 gives me 24.5. Okay. Then I go down to the lower half, and I say I want the median of the lower half, so 1, 2, 3, 4, 5, 6. So these two would be in the middle. So I do 21 plus 22 divided by 2 is 21.5. 1, 2, 3, 4, 5, 6. Again, we want the 2 in the middle because it's an even set. So it would be 26 plus 26 divided by 2, which gives me 26. And that is my 5-number summary. Okay. They're not too hard to find. Just got to have kind of your wits about you to find it. All right, well, what's the next step in this process? Because we're leading to something. Well, the next step is going to be to find an outlier. So, what is an outlier? And I kind of mentioned it in the last lecture a little bit, but an outlier is a point that is very far away from the data. Outliers can be important to statistics as they can refute claims if they are significant enough. We'll talk about that a little bit later when we talk about hypothesis tests and what it means to be significant or not. But we need a process to confirm the outlier, so we have a couple of steps. First off, we have to calculate the IQR, which you saw me calculate on the first one. Then you take the IQR and multiply it by 1.5, and it's always 1.5. Then you take the number from B, add it to quartile 3, and subtract from quartile 1. That's a little confusing when you first hear it. I'll show you the whole process with that once I get there. And this will form a range of numbers. Anything outside this range is an outlier. So what we're going to do is we're going to find the outliers if they exist on the three data sets that I've already done over here. Now the big thing about outliers is this. They don't have to exist. It doesn't have to be an outlier. And there also doesn't have to be just one. You can have multiple outliers on either side of your data. So let's see if we can find some outliers. So the very first step here was to calculate the IQR. And we've already done that. It's right here, it's 6. There it is. Okay? The next step is going to be to take that 6 and multiply it by 1.5. And it's always 1.5, so don't stress that one too much. So 6 times 1.5 is 9. Okay, now I'm going to take Q3. Q3 is 16. I'm going to take Q1. Q1 is 10. I'm going to add this 9 that I just got to Q3. And I'm going to subtract this 9 from Q1. So they're independent of each other. And let's see, I'm going to get 25 and 1. Okay, so now I've got this range here. And I like to call it the acceptable range. Because basically anything in that range is good. It's fine. It's all right. Now, anything in your data set up here that is above 25 or lower than 1 is going to be an outlier. So what I'm going to look for is, do I see any points that are lower than 1 or greater than 25? So I go up here. The minimum's 8, so that's definitely not lower than 1, so that means there's nothing lower than 1. And the maximum is 20, so that means that's lower than 25, so there's nothing greater than 25. Therefore, in this particular case, there are no outliers, which is pretty cool. You know, if you're on the money with your information, you're probably not going to get a lot of outliers. So the next one, let's take a look at it. So the next one looks like this. So we are going to have to calculate the IQR for this one. So let's see. 23 minus 14.5. So it's definitely a 0.5 we got going on here. Let's see, so that takes me up to 15. Another 5 takes me up to 20, so 8.5. Okay, and I'm going to multiply that by 1.5. So let's see, 8.5 plus half of itself. Well, that would be 4.25, so it'd be 12.75. Let's just double check that real fast. Sometimes make wrong answers in my head. Oh good, it's correct. Okay, so now I'm going to take my 23, which is my Q3, and add 12.75 to it. And I'm going to take my 14.5 and subtract 12.75. So let's see what I get. I get 35.75. And when I do 14.5 minus 12.75, I get 1.75. So what I'm looking at here is this. Anything lower or less than 1.75 would be an outlier. Anything greater than 35.75 would be an outlier. The only thing that in this data set that would fit that would be 50. So that means I have an outlier at 50. So that's my only outlier. Again, you can have one outlier or you can have many. Okay, last one real fast before I switch to the final topic. That is this one to find our outliers with. So I'm going to do the IQR, again, Q3 minus Q1, 26 minus 21.5, so 0.5, so it'd be 4.5, okay, times 1.5, so it's 4.5 plus half of itself. That would be 2.25, so it'd be 6.75. Okay, and then 26 plus 6.75, and then 21.5 minus 6.75. This one's easy. This is 32.75. This one's a little bit harder, so let's see. I'll just go ahead and I'll be lazy for a couple of seconds and just go ahead and throw it through the old calculator real fast and get 14.75. Not to say that everyone who uses calculators is lazy, but you know, as I've studied math, I should probably be able to do most of this in my head. Okay, so that's my acceptable range. And if I look up, turns out that this particular one has a ton of outliers. Specifically, 3 and 4 are less than 14.75, and 56 and 67 are also less than, are greater than 32.75. All right, final thing we're going to talk about with this topic is an actual box plot. And it all flows from exactly what we've been doing. So box plot is a visual representation of the 5-number summary and the outliers. Now, it's also known as a box and whiskers plot. Something that terminology I don't use because when you take AP Stat courses and you do the tests, apparently they take points off for using the term box and whisker plots. I don't know why, but they do. But the median and the quartiles are all represented by vertical lines. The minimum and the maximums are represented by points, and the outliers are represented by asterisks. So we're going to take all the ones that I've already calculated, and we're turning them into box plots. So here's the very first set of data that we calculate here. So let's see. I'm going to go ahead and turn this into a box plot. Now, when there is no outliers like this particular one has, it's actually pretty easy. let's see. I didn't technically need to put that axis in, and I probably won't do it for the next one, but what I do need to do is just scale the bottom here. And again, just like all graphs, you can do it on the x-axis, or you can do it on the y-axis. I prefer to just do it on the x-axis. That's just me. You guys can do you. Okay. So now I'm going to draw all the members of the 5-number summary. And the way I like to do it is I apply what I call the Titanic rule, which is start on the inside and work your way out. Because that's what the character, when they went to go eat dinner and he asked, what do you know to eat? She said, I just start on the inside and, work my way out. I thought it was funny. Okay, so, we're going to start from the inside, which is the median. And we look up here, the median is 13. So what I'm going to do is I'm going to draw a line, a vertical line at 13. And there's no specific length to what that line has to be. So don't look for something like that. And there's no specific distance off the actual x-axis. I would just not put it on the x-axis, but technically speaking, you can. Then I'm going to go with Q1 and Q3. So again, those are going to be vertical lines. And what I want to do is I want to make them the same size as my median. And then what I'm going to do is I'm going to connect all three, just like this, to create the box. And so now, for my minimum and maximum, what I'm going to do is I'm going to put points. Got one at 8. Got one at 20. And you're going to try to make them kind of like in the middle of where the line is. And you're going to connect them right back to the box. And so we got a box and whisker plot. Or a box plot. Just like that. Okay, so let's look at what happens when you have an outlier. Okay, so now this particular set had an outlier at 50. So when I draw this, something different's going to happen. So let's see. And I didn't have to draw that y-axis. I'm not going to do it this time. It's kind of a lot of numbers to get from 12 to 50, so we'll start at 12 here. We'll go every 2. Okay, so once again, the median is 19. The Q1 is 14.5, which will approximate, it's about right there. Q3 is 23, it's halfway through. And we're going to go create our box. Now, 12 is fine. It's not an outlier. So we're going to put a point there and connect it back. Now the problem that occurs, the problem that occurs is the 50. The 50 is a problem because it's an outlier. So what I'm going to do is I'm going to put an asterisk at the 50, just like that. Like a happy little asterisk. Now, I do still need a maximum. So what I'm going to do is I'm going to go back up here. See, I can't have my 50 be my maximum anymore because it's an outlier. So the 50 is straight out. What I'm going to look is next to it. If the one next to it is not an outlier, I'm going to use this now as my max. So I'm going to go back down here and do 25. And that is my box plot for that. It has one outlier. Now, as you'll see in the next one, if it has multiple outliers, you do have to actually put an asterisk on all of the outliers. So Let's look at that real fast. Okay, so last one we're doing right now. This one goes from 3 to 67, so I can probably do something similar. So again, I'm gonna go every 2. So 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31. Uh-oh, I might run out of room here. Let's just get these a little closer in. 35, 37, 39, 40. Oh, you know what? We're going to scratch that out. Okay. So we're going to have to go by 5s, I think, to stretch it. So we'll start with 3. And we'll go every 5. So 3, 8, 13, 18, 23, 28, 33, 38, 43, 48, 53, 58, 63, and 68. Okay, so we can still do our median at 24.5. So we'll have to approximate this. So 24.5 is about right there. We have our Q1 of 26, which is right about there. And then 21.5 is right about there. We'll make our box. Now this has outliers on both sides. So we know we have outliers at 3, 4, 56, and 67. So I'm going to put an outlier at 3. I'm going to put an outlier at 4. I'm going to put an outlier at 67. I'm going to put an outlier at 56. Now once again, you need points for the max and min. Well, if I go up here, so let's see. If I look at the left here, that can't be the min, that can't be the min, so 21 has to be my min. That one can't be my max, that can't be a max, so 26 has to be my max. Now, for the 26, that just means that the Q3 and the max are the same. So I'm just going to put a little point right there on the maximum. And then, over here, it's technically not on there, because it's 21. So make a little line. And that's it. Spread, box plots, and outliers.